Here we have a very small amount of 99% potassium nitrate salt, and we are going to use it in combination with our very impure sulphuric acid to try and make some nitric acid. Again, this is just a test run to see if we get any result at all. So it's not really going to be perfect, but it'll be better than nothing. So our salt should react with the sulphuric acid to make nitric acid. You can do this all in one flask with the same amounts if you're going to combine them later anyway, but I want to do them separately first so that I can then test the nitric acid by itself without the sulphuric acid, and then I can recombine them again later to do what I want. So we're going to pour off roughly half of this. Should be about half into here. And that should react to form nitric acid. So hopefully there should be nitric acid in there. I'm going to add a tiny bit more. Okay, perfect. I'm going to set that on there. And clean that up. Okay, so I added a tiny bit more potassium nitrate in excess just to make sure that we don't waste any of our sulphuric acid in making the nitric acid. So hopefully in here should be just nitric acid, excess potassium nitrate, and potassium sulphate, potassium bisulphate I think it is. I will test a tiny bit of this to see whether it is nitric acid or not. I really don't imagine the concentration to be that strong, but that will be pleasing if we get a result out of it. So place a small amount on there. Not much, so I really don't imagine the concentration is anything to behold at all. But again, just a test run. But yeah, no reaction there. So actually, after a second, I am noticing small bubbles forming, so there is gas being made. So I believe that that is the nitric acid actually reacting with the copper. So in theory and by practical observations, I can probably safely assume that that is nitric acid that we have made. We have upgraded to a plastic tray because of concerns with the carpet, but now we're going to add a thermometer and combine our sulphuric acid with our nitric acid. I do want to keep an eye on the temperature though, because although it's going to be very small, there should be a slight temperature change, and it should give me a small gauge of how concentrated the acids are. So we'll give the thermometer a second to settle and come to temperature with the acid, but the acid should also be at room temperature, so it shouldn't be too dissimilar. I'm going to add a small amount just to see if we notice any changes. Which we shouldn't. Although now thinking about it, excess potassium nitrate could actually react with the sulphuric acid to just make more nitric acid, and we don't want that to happen. So I think we should actually get rid of all the solid by maybe adding the nitric acid into the sulphuric acid, so let's do it the other way around. So add the thermometer to this one, and hopefully in this conical flask there should only be sulphuric acid and a small bit of copper sulphate, hence the blue colour. But in here, if we do it with a beaker, most of it is settled to the bottom, so we can add it in. We might actually be able to, let's see, oh yeah, most of it. There we go. That should be most of it. It doesn't look like there's a significant temperature change, which is expected. But that should be most of the acid. Now combined. So we should there have a nitration bath. A small amount of leftover sulphuric acid in that one. Nitric acid, sorry. That should all be in there. Yeah, no temperature change, which does indicate a very low concentration. But from adding the nitric acid to the copper metal, it actually did react and made copper nitrate and nitrous oxides. So the nitrous oxides just left as gases, but you can see here that copper nitrate has dried on the surface. So yeah, that was a good test. But I don't think we need that thermometer, because it hasn't really reacted. Well, it has reacted, but it hasn't really shown significant concentrations, which again was expected. So now we should have, in theory, a nitration bath or a nitration acid that we can use to nitrate various chemicals.